Hi and welcome to today's lesson. Today's lesson is all about potential difference. So by the end of the lesson, I just want you to know what potential difference is, how it's measured, and be able to draw circuits with measuring potential difference and be able to do some calculations that involve the terms potential difference. Okay, you've actually probably heard of potential difference before, but you've probably heard of it in a different format. Okay, so we'll just talk about it a little bit today. So before we start, here is 6 circuit symbols. I will just move myself into the middle so I'm not in the way. 6 circuit symbols. If you're following along with the lesson worksheet, next 1 to 6, can you write down the name of these circuit symbols? Okay, so pause the video now. 1 to 6, what are these circuit symbols? Okay, so you should have had a little go at them by now and just written down what their name are. So number 1 is a cell, not a battery, it's a cell. Okay, battery is made up of multiple cells and that's actually number 4. Number 4 is a battery. Number 2, a switch. Number 3 is a variable resistor. Notice it's got the little arrow going through it, which shows it's a variable resistor. Without the arrow, it's just a resistor. A variable resistor is a resistor we can change, okay, that we can alter its resistance. We're going to come to next couple of lessons what resistance means. Number 5 is a voltmeter, and number 6 is an ammeter. Now, what does number 5, what's it used for? And number 6, what's it used for? Okay, so pause the video again. If you're following on the worksheet, what is number 5 used for? What is number 6 used for? Okay, so you should have answered what number 5 and number 6 are used for. So I'm going to start with number 6. I know it's a bit random, but I'm going to start with number 6. So 6 is an ammeter. An ammeter is used to measure current. Okay, so an ammeter is used to measure the current in a circuit. Current is measured in amps. Okay, not ants, not it's amps, ampere, okay, A-M-P-S, okay. A voltmeter. Now, a lot of people would say that a voltmeter is used to measure voltage, but you're now on to GCSE and we don't say voltage, we say potential difference. And that is what we're going to be looking at, what potential difference means today. And a voltmeter measures potential difference in volts, okay. So that's the start of an introduction to our lesson. Okay. So here's a nice little model. I'm just going to move my head back over here. Here's a nice little model for us to start thinking about, okay? So we've got in this circuit a battery, we've got a bulb, and we've got these little people going round. And you notice these little people are carrying sacks. So the little people going round actually they represent the current. And current, remember, is the flow of electrical charges, the flow of electrons, electricity, flow of electrons going around the circuit. So, excuse me, the electrons flow around the circuit and we can see the little man going around the circuit. He's not used up. Current isn't used up. It goes from the battery round to the bulb and back round again. So it just carries on. The electrons flow around the circuit. The electrical charges flow around the circuit. And last lesson we talked about current and we talked about charge, and that's what we're measuring. Those electrons, those charge of those electrons flowing around. So think back to chemistry, electrons on the outer shell of atoms, the electrons on the atoms, what charge electrons have. They've got a negative charge. See how it's starting to link with other concepts you've learned? Okay, and those electrons are flowing around the circuit. So those little electrons you can see in this model are carrying things, and they're carrying the sacks of energy going from the battery to the bulb. It delivers all that energy to the bulb. It's got no energy left and goes back to the bulb to collect some more energy. So the energy is the potential difference. That's what we're talking about. So if a battery has got 6 volts, okay, and the little electron is carrying that 6 volts of potential difference to the bulb, it gives all of that 6 volts of potential difference to the bulb, and then off it goes again, back round to the battery to collect some more energy, some more voltage, some more volts, okay. If it was a 2-volt battery, then all he's got in his sack is 2 volts. Now, what do you think would happen if we put more than one bulb in the circuit? So if he's got, we'll carry on with the 6 volts. He's got 6 in his bag. He's going to the first bulb. What would he give all of it to the first bulb? What would happen? So think about what would happen if he has to go, if the little electron has to visit 2 bulbs. What do you think will happen? Okay, so let's have a little look. So potential difference, okay, is the measurement of how much voltage there is before the bulb. So I'm just going to here. So here we've got our battery. If it's got 6 volts, we've got 6 volts going round here, going to our bulb, being carried by our electron, and then nothing left on this side. So I can measure the difference between the 2 points. So on this side here, over here, oops, didn't mean to click. Over here, okay, we've got 6 volts. Those electrons are carrying 6 volts of energy. Over here, how much energy are they carrying? That's right, nothing, because they've delivered it all here. So the difference between 6 and 0 is 6 volts, and that's the potential difference, the difference between one thing and another, okay? And that's why the voltmeter must be in parallel. It must go round something. It must be in parallel. We'll look at what parallel means in a couple of lessons, but it goes around the bulb. We could put a voltmeter around the battery over here, and we could measure how much voltage going out. So 6 went out, and there'd be 0 coming back in. Those electrons would be carrying 0. So with the difference between those two places would be 6 volts, and that's how we would know what the battery voltage is. The potential difference, the difference between how much energy those electrons carry in one place and in the next. Okay, so let's have a look. We've got our voltmeters in parallel that go around these bulbs. I know it's a bit of a dodgy diagram. They go around these bulbs. And look, we've got it going around the battery here. Again, a bit dodgy diagram here. Okay, so if this was a 6-volt battery, what would happen? What would we measure? If it was just 1, if we got rid of all of this, okay, if it was just 1, we know that 6 volts would be here and 6 would be here, because the electrons would be carrying 6 volts when they left here, and then they would give it all to that bulb, and then they'd go back with nothing. So the difference between 6 and nothing is 6. But what happens when they've got to visit 2? Right, so draw the circuit, if you like, have a little think, okay. So what happens is they share. So if it starts at 6 volts here, what happens? They go to the first one. They know they've got 2 deliveries to make. They give half of it to the first one and half to the second one. So each one would get 3 volts. So can you write a little rule about the voltage in a series circuit? Again, if you're following the worksheet, there's a little place for that. Okay, write a rule about the voltage in a series circuit. Pause the video here. Okay, so now we're in a parallel circuit. And again, we'll talk about what series and parallel mean a little bit later, and we'll go back through this. But what will happen this time? So in a parallel circuit, the electrons go around, they go back to the battery, and then they go around and back to the battery. So they only visit one bulb at a time. So again, if this was a 6-volt battery, okay, what would happen here? So our electrons would carry 6 volts here. They would go here, okay. They're only visiting one thing, so they'd give it all full 6 volts. Then they'd go back, collect some more, go to the next one, and so on, okay? So half the electrons would visit this bulb, half the electrons would visit this bulb. So that's the current, and that's the current splitting up, and we'll talk about that. But the voltage, how much it carries, how much energy those electrons have got, it would give its full 6 volts just to one bulb before it went and picked up another. So again, can you write a little rule about the voltage in a parallel circuit? So pause the video, have a little go at that task. Okay, so let's have a look here. So in a series circuit, the voltage is shared between the components. So if we've got 12 volts, how potential difference would this voltmeter read and this voltmeter read? So this voltmeter over the battery is reading 12 volts. How much would this one read? How much would this one read? Okay, remember it's shared, so each one would receive 6 volts. Okay, again on this one, so this one we've got a parallel circuit with the branches. The electrons only visit one bulb at a time. Okay, so it's got 12 volts being measured in this potential difference in parallel around the battery, 12 volts. It goes and visits the first one, then goes back and gets another one. So how much would the potential difference be read here and here? Okay, each one, it would receive the full amount of energy, so it would receive 12 volts. So what would that look like in the bulbs? This one's on the blue side would only get 6 volts, whereas the ones on the purple side would get 12. So what would that look like to an observer? Okay, what would the difference be? You'd notice that the ones in parallel would be brighter. Yeah, brilliant, well done. Okay, so here's a little progress check. So pause the video, go through these, they're on the worksheet, okay, or write down your answers if you're not using the worksheet. I don't need to read them, you can read them. So pause this and have a little go through what we've just covered. Okay, so let's just... Right, so what we've looked at is we've revised the current and the circuit symbols. We've talked about current, those electrons, the electrical charges flowing around the circuit. We've talked about the unit potential difference, volts. We've named the equipment used to measure potential difference, a voltmeter, and we've talked about the fact that it has to be in parallel, it has to go around a component in an electrical circuit. So now we're just going to look at the last objective, describing the effect of a larger potential difference. So the way we're going to do that is we're going to start looking at a calculation. So potential difference is energy divided by charge. Okay, so that's V equals E over Q, sorry, charge is Q, don't ask. V equals E divided by Q, okay? So you can't change the symbols, you can't put your own ones in. So charge is the symbol is Q, but it's measured in coulombs, which is a capital C. Energy, you know this, is measured in joules, and potential difference is measured in volts. Not voltage, potential difference, okay? Keep remembering that. So these are the options rearranged. So you might be familiar with formula triangles, okay? So if the energy is 10 joules, the potential difference is 10 volts, the charge is 10 coulombs, okay? Volts, joules, coulombs, okay? So here you go, right? 4 questions for you to have a little go at. They're on the worksheet. Pause the video and then we'll go through them together in a minute. So pause, have a go. Okay, so question 1, how much energy is converted if 10 coulombs of charge pass through a 6-volt battery? So what we were being asked to work out, we're being asked to work out how much energy. Okay, so it's potential difference times the charge. So we've got 6 times 10 would give us 60 joules of energy. Don't forget to write out the formula, number, answer, units. Fat nouns are useless. Formula, number, answer, units to get the full marks. Okay, question 2. A 3-volt battery is connected to a bulb inside a torch. If after 10 minutes, 300 coulombs of charge pass through the battery, how much chemical energy is converted to electrical energy? Okay, so we've got here the potential difference, 3-volt battery. Okay, if after 10 minutes, 300 coulombs of charge pass through the battery, how much chemical energy is converted to electrical energy? So what we're going to do... that one didn't come up, sorry. Okay, so what we need to do is we need to work out how much charge. Okay, so we've got 10 minutes, 300 coulombs of charge passing through the battery. Okay, so we need to work out the energy. 300 coulombs of charge times the 3-volt battery. So 300 coulombs times the 3 gives me 900 joules, and that's 900 joules per second, and then we need to times that by how many seconds are in 10 minutes. So there's 60 seconds in 1 minute, so 900 times 600. Okay, I'm not doing that in my head right this second. Number 3, a mobile phone battery is labelled 3.6 volts. If the battery supplies 2 joules of energy to the phone, how much charge has passed through it? So this time we're working out charge. So we're going to do charge is energy divided by the potential difference. So energy is 2, potential difference is 3.6. Okay. That's the top one, isn't it? That's totally messed up, isn't it? So this one here, it goes with question 2. 2 divided by 3.6 is 0.56 coulombs. So that one goes with question 3. Sorry about this, a bit of a mess. Question 4, if a 1.5 volt torch operates with a current of 2 amps, how much energy does the battery supply to the circuit after 10 minutes? Okay, so we're looking at energy again. So energy, how much energy? Okay, so we want potential difference times the charge. So we've got the potential difference is 1.5 volts. Okay, but we don't have the charge. What we have is the current and the time. Now remember, charge equals current times time. Okay, so we can work out the charge by 2 amps times, not 10 minutes, because we need to get that into seconds. Okay, so charge equals current times 2 times 10 times 60, so that gets it into seconds, gives me 1,200 coulombs. Then we can put that into our equation here. energy equals potential difference times the charge. So we've got the 1.5 volts potential difference times the 1,200 that we just worked out charge gives me an answer of 1,800 joules. Okay, sorry that it got a little bit messed up on there for you. Okay. So last little one, progress checks. So can you describe the effect of a large potential difference? Use a sentence. A potential difference is some components have a bigger or smaller what. They therefore use or add what. Okay, so have a little go and see if you can use this. Okay, so this time we're talking about the effect of resistance. Okay, so resistance is how hard or easy it is for the flow of the current to go through that component. Okay, so potential difference, what it is, remember our little man with sacks, some components have bigger or smaller resistance, so I'll give you that one. So that's the impact that it will have on the current flowing through. Okay, so have a little think about this. Here's a formula, you know, it's in a formula triangle, maybe that will help you. Okay, so have a little think about that one. Okay, it's on the worksheet, and that's the end of this lesson. Thank you very much.